Hello students. Before we dive into our topic today, I want to give you a brief overview of what we will be covering in this session. Today we will be exploring about the bricks, brick masonry, types of bricks and some important terminology. We will discuss mainly the points like number 1 overview of brick masonry, number 2 importance of brick masonry, number 3 introduction of bricks, fourth manufacturing process of bricks, fifth will be what are the different types of bricks, the sixth classification of bricks, and seventh important terminologies. An overview. Brick masonry comprises of bricks units bonded with mortar. The primary components, that is the bricks and mortar, are crucial for the stability of structure and its integrity. The bricks provide the fundamental building blocks, whereas the mortar acts as the adhesive, ensuring a durable bond and distributing loads evenly across the masonry. Bricks are modular building units which are commonly made from clay, shale. These units are integral to the construction, particularly in masonry, due to their durability, thermal insulation and the load bearing capabilities. Bricks can be classified based on their composition, size, shape and intended use. The most common typical types include number 1 common bricks. These are standard bricks without any special surface treatment used for general construction purposes. Facing bricks. These are manufactured with improved appearance and durability. These bricks are used for visible surfaces. Second is engineering bricks. It is characterized by high compressive strength and low water absorption. They are ideal for the load bearing walls and damp environments. Next is fly ash bricks. These bricks are made from fly ash, lime, gypsum. They offer an environmentally friendly alternative with good strength and low porosity. Next is the importance of brick masonry. The brick masonry is often preferred because of number 1 uniform size and shape of the bricks allow for various patterns to be formed. Second is they are lightweight and small size made bricks easy to handle. Third is the bricks require no dressing and can be done by unskilled masons. The bricks are readily available at most sites, unlike stones. Fifth is ideal for constructing lightweight partitions and filler walls. Now the introduction of the bricks. Bricks are a type of building material typically made of concrete, sand, lime or clay. They are generally used to construct walls, pavements and other types of architectures. Bricks can be produced in a variety of shapes and types depending on the materials used to make them and the use for which they are intended. In a simple language, it can be defined as brick is a hard block of baked clay that is used for building houses, etc. Bricks are arranged in various patterns or bonds so as to distribute the loads evenly and enhance the structural integrity of the walls. The most common bonds include the stretcher bond, header bond, English bond and Flemish bond. Now we discuss about the manufacturing. Manufacturing of bricks are completed in following steps. Number 1 is preparation. The raw materials are mixed and ground into a fine consistency. Second step is molding. The mixture so prepared is shaped into bricks using a mold. Next step is, after taking out these material from the mold, the bricks are air dried so as to reduce the moisture content. In order to gain strength, the next step is firing. These bricks, after drying, are fired into a kiln at temperatures varying from 900 degrees centigrade to 1200 degrees centigrade. This enhances their strength and durability. After firing, it requires cooling. The bricks are gradually cooled so as to avoid any kind of cracks because of the sudden cooling. Now, let us understand the preparation process of bricks in detail. The first one is production method. Bricks are produced through a process that involves molding clay into uniformly sized rectangular blocks. These molded blocks are then dried and subsequently fired in a kiln. Now, composition of clay. The clay is the primary material which is used in brick making. It is a malleable substance primarily consisting of sand and alumina with minor components like chalk, iron and manganese dioxide. The quality assurance. In order to ensure the durability and hardness, the bricks must be adequately fired. The effectiveness of the firing process can be verified by the distinct ringing sound that occurs when the two bricks are struck together. The high quality bricks should be free from cracks, chips and any kind of significant lime particles in the surfaces. Now we come to the different types of bricks. Based on the manufacturing process, mainly bricks are categorized into two ways, that is, number 1 is traditional bricks and the second is modular bricks. First, the traditional bricks. The traditional bricks lack standardized sizes, resulting in variations in the size depending on the local practices and the materials that are being used in that particular area. Typically, they range from 20 to 25 centimeter in length, 10 to 13 centimeter in width and 5 to 7.5 centimeter in thickness. These variations can impact mortar joint thickness and the alignment of the masonry. Despite this, a common nominal size of traditional bricks is 23 centimeter by 11.4 by 7.6 centimeter, though actual sizes may vary as I just told. Modular bricks. Modular bricks are an advancement in the bricks manufacturing, providing uniformity and enhancing the construction efficiency. Standardized by Bureau of Indian Standards, that is BIS, their nominal sizes are 20 centimeter by 10 centimeter by 10 centimeter and the actual size is 19 by 9 by 9 centimeter. They are more economical to manufacture, require less amount of drying and the stacking spaces, and reduce mortar and labor cost, making them ideal for masonry construction projects. Classification of bricks. Based on their quality, the bricks are classified into three primary classes, which impacts their suitability for different type of masonry work. They are first class bricks, second class bricks, third class bricks. The first class bricks are the highest or the best quality bricks, meeting the stringent criteria about size, shape and performance. Their manufacturing and quality. The first class bricks are made from high quality plastic clay, which is free from any kind of impurities and saline deposits. They are uniform in color and exhibit a consistent texture. The firing process is carefully controlled in order to ensure the bricks are fully burned and achieve the desired hardness. Physical properties. The first class bricks produce a clear ringing sound, have straight and sharp edges, even surfaces and are any kind of defect free. They absorb minimum water, showing low porosity and no efflorescence after drying. As far as the application is concerned, due to their superior quality, the first class bricks are used in high-end construction projects, including residential buildings, commercial structures and prestigious architectural works. Now the second class bricks. Second class bricks are slightly lower in quality than the first class bricks, but are still suitable for a variety of construction applications. Their manufacturing quality. These bricks conform to standard dimensions, but may have minor irregularities in the shape and color. They are fully burned and produce a clear ringing sound when stuck together, indicating that they are sufficiently durable. Physical properties of second class bricks. When submerged in water for 24 hours, the second class bricks absorb 16 to 20% of their weight, as again 10 to 12% in the first class. While they may have slight imperfections, their performance is generally acceptable for most of the masonry applications. As far as the application is concerned, the second class bricks are commonly used in less critical construction projects such as boundary walls, partitions and non-structural elements. Now the third class bricks. The third class bricks are the lowest quality in the classification system and are characterized by notable deficiencies. So far as manufacturing and quality is concerned, these bricks are often irregular in size, in shape and also the finishing. They may not be fully burned, resulting in reddish yellow color and reduced strength. Their inconsistent quality makes them less reliable for any kind of structural use. So far as the physical properties are concerned, the third class bricks have low crushing strength and are prone to defects such as cracks and poor finishing. Their incomplete burning can lead to higher water absorption and potential issues with relation to the efflorescence. So far as applications are concerned, due to their lower quality, third class bricks are typically used in a non-load bearing applications or where high strength is not at all required, such as in temporary structures or low cost housing. Now next we come to molded bricks. Molded bricks are a specialized category of bricks which are designed to meet the specific architectural structural requirements. These bricks are produced in various shapes and sizes beyond the standard rectangular form to accommodate unique design elements in masonry construction. The custom shapes of molded bricks are utilized to create distinctive features such as coping, cornices and other decorative components in a building. In enhancing both aesthetic appeal and functional design. Special shapes and sizes. Molded bricks are meticulously crafted in specific shapes so as to serve the various architectural purposes. Coping bricks, they are used to cap the top of walls, parapets or chimneys, providing a smooth and visually appealing finish that also protects the underlying structure from weather damage. Cornice bricks, these are designed to create horizontal projections that the crown of a building. These bricks add detail and shadow lines, contributing towards the architectural character. The bill nose bricks with rounded edges, these are used at corners or the ends of walls to soften sharp lines and enhance the safety and aesthetics. Applications. The primary function of molded bricks lies in their decorative utility and are commonly used in number one, facade design. Molded bricks can be used to craft intricate patterns and textures on the building exteriors, contributing towards the visual identify of structure. Interior features. These bricks are also employed in creating fireplaces, feature walls and other interior architectural elements where a non-standard shape or design is desired. Structural aesthetics. Molded bricks add visual interest and character to buildings, ensuring that even functional elements like walls, columns, and arches possess an artistic quality. Now, technical consideration. Number one, durability. The molded bricks, like their standard counterparts, must exhibit high compressive strength and resistance to weathering in order to ensure longevity. Dimensional accuracy. The precision of the molding process is critical to ensure the bricks fit together seamlessly in construction. Material quality. The choice of clay and additives used in molding affects the brick's final texture, color and durability. Molded bricks thus represent a fusion of functionality and artistry in any brickwork, allowing architects and builders to achieve both structural integrity and aesthetic innovation in masonry construction. Now, the terminologies. We will explore some essential terminologies and construction techniques related to brickwork. Now, understanding these terms is crucial for effective masonry and structural integrity in any of the construction projects. Number one, stretcher. Stretcher refers to the longer face of brick measuring 19 by 9 centimeter when viewed in elevation on a wall. This is the face that is primarily displayed in masonry when all bricks in a course are oriented such that their longer faces is exposed. This arrangement is termed as stretcher course or stretching course. This method is commonly used to create a uniform and aesthetically pleasing surface on the wall. Second, header. A header refers to the shorter face of the brick, that is 9 by 9 centimeter, used in masonry. When visible in wall elevation, it forms a heading course, creating specific visual effects and structural patterns. Third is lap. Lap is the horizontal distance between the vertical joints of successive brick courses. Proper lap prevents vertical joint alignment, enhancing structural stability, aesthetics and water resistance in construction. Next term is perpend. A perpend is an imaginary vertical line through the joint between adjacent bricks, ensuring the correct alignment within a course. Accurate perpendicular alignment is essential for maintaining the structural integrity and the stability of the wall. Next term is bed. The bed of a brick is its lower surface, that is 19 by 9 centimeter, that contacts mortar, forming a secure bond. Proper bedding is very crucial for the strength and durability of masonry construction. Next term is closure. A closure is a brick segment that is cut longitudinally to close the gaps at the end of a course. This helps in preventing vertical alignment of joints between the successive courses, which is essential for structural stability. There are several types of closures like queen closure, king closure, beveled closure and mitered closure. We will take up first the queen closure. A queen closure is a brick cut lengthwise into two equal halves, each retaining the brick's full height and width, but the width half of the length. This cut is used at the ends of the walls or near corners so as to complete the bond pattern, ensuring that the vertical joints are staggered. Second is the queen closure half, a variant where the brick is cut into two halves its width. This piece is used to make finer adjustment at the junctions, helping to avoid the joint alignment and maintain the structural integrity. Queen closure quarter. This cut is to 1/4 of a brick's width and is used for even more precise fitting wherever it is needed, typically in complex or tight spaces. The second is the king closure. A king closure is a triangular brick cut with 1.5 the width of a full brick, resulting in both half header and half stretcher faces. This is used at corners and other junctions to ensure a tight, structurally sound bond, particularly where a wall meets another structure or end at a corner. Now the next is beveled closure. A beveled closure is a type of king closure with a tapered cut, reducing the width smoothly from full to half. This gradual taper is used to create smooth transitions in the masonry, maintaining the bond pattern while avoiding the abrupt changes in brick size. Next, fourth one is mitered closure. A mitered closure features an angled cut, typically 45 to 60 degrees, creating one full length face and one shorter face. This cut is used at angled joints like in a bay, windows or octagonal structures, ensuring a clean, precise fit that maintains the wall's structural integrity and visual appeal. Precise cutting is crucial for fitting closures into the bond pattern, maintaining both structural strength and visual continuity. Closures prevent vertical joint alignment, distributing the loads evenly and enhancing the wall's durability. Beyond structural use, they also contribute to the neat appearances of brickwork, especially in complex design or decorative patterns. This is something very important because the vertical alignment at any particular location is to be avoided in continuation, because that disturbs or that may hamper the strength. Next is bat. A brick cut across its width and creating a shorter length. Variants include half bat, that is half length, 3/4 bat, that is nothing but 3/4 length, and beveled bat, that is beveled width. So that comes under the types of bat. Next is arris. The sharp defined edge which is formed where two brick faces intersect, essential for achieving clean lines and precise detailing in any masonry work, impacting both the finish and overall aesthetic. Next one is bull nose. Bull nose is a molded brick with rounded edges, just like that of a nose of a bull. It's available as a single or double bull nose. If it is done on both the sides, double bull, otherwise single bull. These bricks are used in copings and areas where rounded corners are preferred, maybe for aesthetic or structural or architectural purposes. So they satisfy the requirement. Next is splays. The splays are molded bricks which are designed for architectural detailing, such as plinths, splay stretches and headers. Create stepped or slope effects in any brickwork. It is going to enhance both the aesthetics and structural integrity. Next is dogleg or angle. Dogleg bricks are molded to form the bonds at angles other than the right angle, ensuring a secure bond in different complex designs, making them preferable to mitered closures. Next is quoin. A quoin is an external wall corner, typically at right angles, but can also be at angle over 90 degrees. Quoins enhance the structural integrity and offer an aesthetic finish to building corners. The frog or kick. The frog in brick construction is a deliberate indentation or depression typically located on the face of a brick. Their features is crucial for improving the bond between the bricks and mortar, thereby enhancing the overall structural integrity of the masonry. The frog serves multiple technical purposes, primarily related to the mortar adhesion and stability of the brick within the wall, because when the mortar is filled, the mortar gets into the frog and creates a better bond. The frog is also used for giving the designation or the manufacturer's logo. The functions and design. Mortar adhesion is the primary function. The primary function of the frog, as I just shared, is to increase the surface area for mortar contact. When a brick with a frog is laid, frog up, that is with the indentation facing upwards, the mortar fills the depression, providing a stronger bond when it dries up between the brick and the surrounding masonry. This enhanced grip reduces the likelihood of any kind of slippage or displacement, particularly when load is applied. Second is the bonding strength. The additional bonding that is being generated because of this frog, provided it contributes to the overall strength of the wall. The indentation allows the mortar to key into the bricks, which is especially important in load bearing structures where shear forces could otherwise compromise the integrity of the masonry. A very important part is the structural consideration. The presence of frog significantly impacts the laying process and the final strength of the masonry. Bricks with frogs must be oriented correctly in the sense the frog up, so as to maximize their effectiveness, the reasons we have just discussed. Incorrect orientation like laying a brick with frog down can lead to reduced bonding strength and the potential structural weaknesses, particularly in the load bearing wall, is observed. Next is racking back. The racking back is a method of ending a wall with a stepped pattern, facilitating future masonry integration. This technique ensures a strong bond when extending the wall horizontally. So, this particular arrangement is going to be very useful when we want to extend the construction using the bricks. 15th is toothing. Toothing terminates a wall by projecting alternate courses, creating a bonding surface for horizontal extension. So, whenever the future extensions are to be done, this kind of arrangement is going to be highly useful. This technique, that is the toothing technique, ensures continuous integration with the future masonry work. So, with this we have learnt about the bricks, how the bricks are made, how the selection of the materials are done for the purpose of the manufacturing of bricks, their importance, and also in overall or in totality what are the different procedures that are adopted for the manufacturing of the bricks, as we have to have not only good shape, size, but also the strength, and multiple uses can also be done. So, depending upon the procedures and the type, the different classifications, the bricks are used for the different purposes as discussed in the classification, that is class 1, class 2 or class 3 bricks. Also, the bricks, if it is overburnt in the process, they are also called as the jhama. Even that is also used for the purpose of filling the locations. So, and finally, we have seen what are the different bonds, their purpose, and how these bonds are developed. So, this is all about the bricks, their manufacturing, their types, the terminology and the range of use where the bricks can be. Thank you.